All right, on to 7.2. So now we're going to go into multiplying the rational expressions. Multiplying the rational expressions is, again, just like a fraction. So let's talk about multiplying fractions. When we multiply fractions, there's a couple different ways you can do it. Let me change that to 3. It'll work out better for us. All right, so when you multiply fractions, there's a couple different ways you can do it. You could multiply straight across, right? You take this, multiply straight across, and get 42 over, well, that's a big number. What is 189? And then simplify that. But that's not the easiest way. The easiest way really is once you think about multiplying straight across, these two numbers are both on top and these are on the bottom. So you can go ahead and kind of simplify from here. If I divide this by 7, I get 2. Divide this by 7, I get 1. If I divide this by 3, I get 1. Divide this by 3, I get 9. So just 1 times 2 is 2. 1 times 9 is 9. And again, what you're really doing there is you're breaking down the 3. 3 doesn't break down. 14 breaks down to 2 and 7. And 27 breaks down to 3 times 3 times 3. So really what I'm doing is I'm just crossing out what's common. 7, 7, 3, 3. So that leaves me with a 2 and 2 3s, which is 9. So that's exactly how we're going to multiply rational expressions, is we're going to break down this one, this one, this one, this one, and then see if they cross out. So multiplying ends up just being a bigger simplifying problem. Simplifying, what we did was we broke down the top and the bottom and then crossed out. So here we have 2 tops and bottoms in the first and the second one. All right, so this one, 5x 4y. All right, so if I'm multiplying these right here, this one we don't have to do a whole lot of breaking down to start. But again, I multiply straight across. So that number's on top and that number's on top, and these two are on the bottom. So now I just cross out what's common here, x on top, x on bottom. And then I have 1 y on top and 2 on the bottom, right? So I end up with just 1. So 5 times 4 is what's left on top. Y times x, nope, the x is gone. So just 9 and y are on the bottom. So 20 over 9y. So really on that one, we don't have to break anything down. It's just crossing out what's common on top and on bottom. On this one?
Yeah.
This one.
Yeah, I see where you're canceling out, but where then you go 5 times 4, right?
5 times 4 is 20, yeah.
Oh, 20.
All right, so here, again, those two are on top and these are on bottom, but let's simplify. Can't simplify this one. Can't simplify that x, but what can I do right here on the bottom left? Factor out of 3 and get x minus 5. What can I do in the upper right-hand corner here? Factor out an x and get x minus 5. And then I guess you can't do anything to that 6. So you get x minus 5 and x minus 5 to cancel out. Is that it? That's it. So you have x times x is x squared, and 3 times 6 is 18. So we're simplifying in all 4 spots and then canceling out and seeing what's left over. Let's get one of these. X squared minus 49. All right, so here again, looking at everything across. So in the upper, what can I do to this one? Not an X there. What? There's none. Right, so X times X is X squared, 7 times 7 is 49, and you do the plus and the minus. In the bottom left, I'm looking at what multiplies to be negative 35 and adds up to be negative 2. Negative 7 and positive 5. I can't do anything on that one. Can't do anything on that one either. So the X plus 5s cancel out, the X minus 7s cancel out, and I end up with just X plus 7 on the top and an X on the bottom. And again, there's 3 terms there, so I can't just cross the X's out. A squared plus 9 minus 10. Negative 3. Positive. All right, so on this one, we got a bunch of simplifying to do on each of those. But here, okay, so what multiplies to be 24 and adds up to be 11? That's 28. All right, so you're close. You're one off. 8 and 3. 8 and 3. So on the bottom one, we'll multiply to be negative 10 and adds up to be 9. Positive 10, negative 1. All right. Okay. Upper right-hand corner now, so what multiplies to be negative 4 and adds up to be 3. Say positive 4, negative 1, right? So A minus 1 and A plus 4. And then the last one multiplies to be 9 and ends up to be 6. 3 and 3, right? All right, so now you've simplified in all 4 spots, so you're just going to see what cancels out. So an A plus 3 cancels out, an A minus 1 cancels out. Is that it? That is it. So I have A plus 8 and A plus 4 on top. And then on the bottom, we have A plus 10 and A plus 3. So we do not have to factor those back out, or FOIL them back out. We can just leave it like that. That'll be fine. They say to write it in factored form, which is what that means. All right, the other thing in this section is dividing the rational expressions, which, again, let's talk about fractions for a second. If I have 2/3 divided by 9/8. Do you remember what you do when you divide fractions? Multiply by the reciprocal. Multiply by the reciprocal, which is the keep, change, flip. You keep the first one just like it is, change the sign to multiplication, and flip the last one, which again is multiplying by the reciprocal. Reciprocal means flip, or flip means reciprocal. So now you do the same exact thing that we were just doing. Well, if you break this down, divide that by 2, you get 1. Divide that by 2, you get 4. Divide that by 3. Divide that by 3. So you get 3/4. Okay, so basically this is the same exact thing as multiplication. Just before we start the problem, just flip the second one. Yes. 6. All right, so again, the first thing when I see that divide, I got to think flip this second one. I'm not going to rewrite it all, flipping it. But I'm flipping the second one. So here I can't simplify the 3x to the 4th at all. X squared minus 25. Can I break it down? X times x is x squared. 5 times 5 is 25, and a plus and a minus. Okay, so now when I go to flip this one, this is actually the top, right? So x minus 5 squared, I'm just going to rewrite it as x minus 5 times x minus 5. Because I know that's what squared means. And then the x to the 6 comes to the bottom. So now crossing stuff out, and cross out the x minus 5. I have 4 x's and I have 6 down here, so that leaves me with 2. So on the top, I'm left with a 3 and an x minus 5. On the bottom, I'm left with an x squared and an x plus 5. Squared minus 7 plus 10. All right, so again, as soon as I see that divide, think keep, change, flip. So flip the second one. So on the right side, x plus 7 doesn't break down, so I'm just going to leave it. That's the left side. On the left side, x plus 7 doesn't break down. This one, if we rewrite it as negative 8 plus x plus 8. Okay, so what did we have to do last time? It was looked like this, where it's negative x. We ended up taking out a negative 1, right? So it became positive x minus 8. So let's just rewrite it like that. We have a feeling that's what needs to happen. So now when we come over here, again, we flip this side. So this is my top. So what multiplies to be 40 and adds up to be 13? Negative 13. Negative 8 and negative 5. And then on the bottom, what multiplies to be 10 and adds up to be negative 7. Negative 5 and negative 2. All right, so now you have what? X minus 5, x minus 5, x minus 8, x minus 8. So we end up with x plus 7 and x minus 2. We have this negative 1, so I'm just going to write the negative 1 out here. Fine, you simplify in all four spots, the top left, the top right, the bottom left, the bottom right. And then dividing, you just flip the second one and do the same thing. The next section is adding and subtracting rational expressions. Kind of splitting this up into 2 days, though. I was going to do it all in one, but I'm splitting it up. Adding and subtracting rational expressions. So again, fractions, if we have 3/4 plus, we do minus 1/4. If the denominators are the same, it stays the same all the way through, and then you just do the 3 minus 1 would be 2. And then at the end, you check and you can simplify if you can. Okay, so if the denominator is the same, you just look at the numerators. Same thing is going to work with rational expressions. If the denominator is the same, no matter how crazy the denominator is, if it's exactly the same, you're just looking at the numerators. There's one other thing that we haven't done in a while that we'll refresh over. If I was subtracting 2 polynomials like this, what was the easiest way to do that? Minus. Just go ahead and distribute this -1 and change that to -x minus 5, and now you can just combine like terms. So x minus x cancels out. -2 minus 5 would be -7. Okay, so we will have to subtract polynomials like this. So it's easier if you just change that sign on the second one and then combine like terms. So you don't have to think so much about the signs. But again, adding, subtracting these with the like denominator, if they're the same, the denominator just stays the same all the way across. Doesn't matter how crazy the denominator looks, it's the same. All right, so like this one right here, what do we have? 3, 6 plus y. Not this one. All right, so here my denominators are the same all the way across. So it just stays the same. I do not add them together. And then here I have 3 plus y plus 1. So you just add in the numerator. So 3 plus 1 would be 4. So it's just y plus 4. And again, you check to see if you can simplify at the end, but we can't on this one. Seven a minus. All right, so again, my denominator is the same all the way through. So it just stays the same. And then I just have 7a minus 28. They're earning like terms, so just rewrite it as 7a minus 28. But now we do have to check to see if we can simplify. So on the top, I could pull out a 7 and get a minus 4. On the bottom, you're looking at what multiplies to be -20 and adds up to be 1. Positive 5, -4. So you have a plus 5, a minus 4. So these do cancel out, and I get 7 over a plus 5. All right, so again, on this one, if my denominator is the same, it just stays the same. I don't mess with it. So now I have this one minus this one. So again, your minus, be careful, make this, I'm gonna go ahead and make this negative 4x and negative 11. So now 5x minus 4x is x. 9 minus 11 would be negative 2. So I change the signs in the second one, then I just combine these like terms. What'd you say?
X minus 2, x minus 7.
So on the bottom, I can simplify the bottom. I'm looking at what multiplies to be 14 and adds up to be negative 9. What, negative 7, negative 2. Negative 2, negative 7. Those cancel out, and I just get 1 over x minus 7. All right, so that's if the denominators are the same. If the denominators are different, somebody said this a second ago, if the denominators are different, you have to find the LCD. I'm going to introduce the LCD today and then probably go back over it tomorrow. You got to know how to do the LCD well, because this section talks about it, and then the next 3 sections uses it. So you're going to need to use the LCD and be able to do it good.